Okay, let's have a look at this one now. So first we shall prove the first case. Prove case n equals 1. So is a1 less than or equal to 2? Well, we're told what a1 is, which is 0. So 0 is less than or equal to 2, so that's true. Okay, 2. Assume case n equals k is true. So that is an, which is root 2 plus, so ak I should say, ak, which is root 2 plus ak minus 1. That's less than or equal to 2. 3, required to prove case n equals k plus 1, i.e. That root 2 plus a k is less than or equal to 2. So for these inequality proofs, usually you want to start with the step 2 and make a multiplication to get it up to step 3. But in this particular case, because there's a recursive sequence in it, it's not really a multiplication. So I think for this case, it might be better to go from 3 to 2 instead of 2 to 3. So for these proof by inductions, often it's very important if you decide to decide first which way to try and prove it. That is, from 2 arrive at 3, or start from 3 and then arrive at 2. With the inequalities, it's usually the case that it's better to start at 2 and work upwards. Although I think in this case, because the recursive sequence in it, it's better to go the other way. So if we start from 3, so from 3, we have root 2 plus ak is less than or equal to 2. And we want to prove that's true. Now if we sub in, let's just call that 0, then ak is root 2 plus ak minus 1, and that's less than or equal to 2. Now this inequality is still true if we square both sides, so you get 2 plus root 2 plus ak minus 1 is less than or equal to 4. And if we take the 2 to the other side, you get root 2 plus ak minus 1 is less than or equal to 2. And that's true. That's true from 2. Now, you might just want, it might be just worth thinking about that might have worked a little bit too nicely. So, for example, if you were to change, say, this 2 to 20, for example, 1 would still be true, 2 is assumed true, and then 3 you're trying to prove this. So that means you're trying to prove this, and you would get 400 minus 2, which is 398. So I guess I'm just trying to demonstrate that I didn't do something silly like sub something true into something true to prove that it's true. Because if I was doing something silly like that, then it would have ended up being true even if I changed this. So this only works, it would seem, because the 2 here and the 2 here. If you start changing those numbers, this inequality won't necessarily work. So I'm satisfied now that this is proven. And then the last step, step 4, is the logic step. So 1 plus 2 plus 3 together means it's true for n equals 1, 2, 3, etc. Yeah. Now there's a bit of confusion over this set here. I know. I remember this. Now hang on. Natural set 0. See, this is a difference in notation. I don't use the subscript, I use the superscript. So I use a star or the 0. And I don't know if that's something that's changed. Let's have a look here. Yeah, you see, the 0 subscript means, at least according to Wikipedia, that it includes 0. But I'm not sure if that's just a difference in countries or just a change over time. This 0 here, it kind of feels like this set's not supposed to include 0 because you're started off by given a 1. So the first case here has to be a1. I guess technically you could work out a0 by working backwards if you know what a1 is. I doubt that's what's going on here, but just in case, let's have a quick look before we wrap this question up. So we have the formula a1, which is 0, equals root 2 plus a0. So that would mean a0 is minus 2. So if we had to start at a0 instead of 1, it's still true because minus 2 is still less than or equal to 2. So yeah, it's also true starting from 0 as well if we had to include the 0. Okay, let's leave that there.